In this video, we are going to be combining two integration methods. We're going to evaluate the integral of cosine of the square root of x using substitution and integration by parts. And if you want to hold on to the second part of the video, I'm going to do another one similar, but with numbers inside and outside of the function. Okay, so for the first one, we've got the integral of cosine square root of x. So the first thing I want to do is take care of the square root of x. So I'm going to do a substitution. Since I know I'm going to do integration by parts, I'm not going to use the letter u because u and dv and v are all used in the integration by parts typically. So I'm going to do a substitution of w. So if we let w equal to the square root of x, which keep in mind that is x to the 1/2 power, okay, take the derivative of that, dw, and you get 1/2 square root of x, and that'll be dx. Now notice that to take the derivative of the square root of x, if it has something else in there besides the x, you have to use the chain rule. Okay, so we'll talk about that on the next one. But since the derivative of x is just a 1, then it doesn't matter in this case. Okay, so we can go ahead and resubstitute. We know that w is equal to the square root of x, so I can put that w right here. So dw is equal to 1/2w dx. And if I solve for dx, move that 2w over, I get 2w dw is equal to dx. Okay, so now I can rewrite my integral with w as the variable. Okay, so this is going to be the integral. Let's see, we're going to have, let's see here, cosine here. And instead of the square root of x, we're going to use that substitution, which is w. Okay, and then the dx right here, we know what dx, it's equal to this right here, so 2w dw. I'm going to write that 2w out front, so let me write it again. 2w and then cosine of w dw. Okay, so there's the integration that we're going to be looking at. We no longer have a square root. Okay, so we're going to use integration by parts. Let me remind you of what that is. Integration by parts said if you have the integral of u v, you can split it up into parts. And that one's going to be, or excuse me, u dv. That one's going to be equal to uv minus the integral of v du. So this is integration by parts. Excuse my little mistake here. dv right there. Okay, so we're going to make this our u. Okay, and we're going to make this our v. Okay, and you'll see why in a second. Okay, so if excuse me, this would be dv, not v. You have to choose dv first. Okay, so for u, we'll say it's 2w. So the du on that, since we have to have du in this, is going to be 2 dw. Okay, and then the dv, which you choose first, dv will be cosine w. And to go back to v, you have to take the antiderivative of cosine, which will be sine. So sine w. Okay, so now I can write this thing down in this form right here using these things here. So we've got this integral equals uv, so that's 2w. Our v is sine w. Okay, and then I will have minus, because of the formula, the integral of, let's see, we've got v du. So the du part is 2 dw. Let's do the v part, which is sine w, and then we could put on that little, for the du, the 2 dw. Okay, so if we clean that up, we can move that 2 out to the front, leave the dw on the end, so that'll be 2w sine w minus 2 times the integral of sine w dw. Okay, so the integral of sine, man, that's messy. The integral of sine is going to be negative cosine, the antiderivative of sine. So this is going to be equal to 2w sine w minus 2, and this right here turns into negative cosine w. Okay, and then we can put our little plus c at the end. The only thing we need to do now, well, first we need to take care of these two negatives, right? It's a -2 times this negative cosine. And then we are going to replace the w back with the original thing that it was, which was the square root of x. So everywhere I see a square root of x, or everywhere I see a w, I'm going to put a square root of x. So I get 2 square root of x times sine square root of x. This, the negatives cancel, so it'll be plus 2 cosine, and then the w is square root of x plus c. And that's the end of that one. Now, if you want to stay on for the second part of the video, I'll do one with some numbers on the inside, which means we'll have to do the chain rule. All right, here we go. Okay, so in this one, we've got an 8 that's sitting out front, and instead of just a square root of x, we've got the square root of 8x. Okay, so I'm going to do it the same way. I'm first going to start with a substitution. I'm substitute for this right here, so w is going to be equal to this, the square root of 8x. Now be careful here, because when we go to take the derivative of this, dw, let's write this as a power, so 8x to the 1/2. Remember, you have to use chain rule since there's something inside here. So you take the derivative of the square root, which is this part, but then you got to remember to multiply by the derivative of the inside. Okay, so this is going to become 1 over 2, and then square root of 8x times the derivative of the inside, which is 8, and that's it's going to be dx. Okay, if we clean that up, dw, the 2's on bottom, the 8's on top, so that will leave a 4 on top. And I'm going to go ahead and convert this square root of 8x into w. So that's what it is right here, and that's dx. So if I solve for the dx, I move that w over, divide by the 4, so I get w over 4 dw is equal to dx. Okay, now I can write this thing out. So the integral of 8 cosine square root of 8x dx. Okay, so we leave the 8 there. Nothing happens to it. Okay, and the cosine, we'll put the w inside there. And in the dx, we'll put w over 4 dw. So w over 4 times dw. Okay, so it's 4 things being multiplied: the 8, the cosine, the w over the 4, and the dw. The 4's on bottom, the 8's on top, so 8 divided by 4 is 2. So we'll stick a 2 out front. Okay, actually, let's just leave it in there. So 2 and w. So 2, this whole thing reduces to 2w, and then the cosine is there, dw. Okay, so just like last time, we're going to use integration by parts. This is going to be our u, and this is going to be our dv, very similar to last time. Okay, recall that integration by parts is the integral of u dv equals uv minus the integral of v du. Okay, so I put the parts in the right place here. So I'll choose u first, which is 2w. Okay, and in the du, take the derivative of that, is going to be 2 dw. And for the second part, I choose dv, which is this. So v, or dv, excuse me, is equal to cosine of w. And if I take the integral, or the antiderivative of cosine w to find v, that's just going to be sine of w. Okay, so now we write it down in the right place. So uv, so u is 2w, v is sine w, minus the integral of v, sine w, du, which is 2 dw. If I put the 2 back out front, connect the sine w to the dw, it looks like this: 2w sine w minus 2 sine w dw. Okay, so when we take the antiderivative of sine w, it turns into a negative cosine. So this is going to be 2w sine w minus 2. This becomes a negative cosine of w. Okay, and then we'll put a little plus c on the end because we don't have any numbers in this, so we have to put a plus c plus a constant. Okay, notice the 2 negatives here, just like last time, will cancel out. So this is 2w sine W plus, because of this, 2 cosine W plus C. Now we substitute. Recall that W is equal to the square root of 8x. That was our original substitution. Okay, so this is going to be 2 square root of 8x sine square root of 8x plus 2 cosine square root of 8x plus C. And that is your answer.